pleased to introduce the speaker for this session, Annie Ma Weaver. Annie works with strategic partners to enable scientists, researchers, and engineers to run HPC workloads on Google Cloud. She has been with Google for more than 12 years in roles including Chief of Staff, Strategy, and Business Development. Before Google, Annie conducted behavioral economics research at Columbia Business School, worked in investment banking in Hong Kong, and consulted for the Scottish Government. Annie received an MBA from the Haas School of Business and a BA in Economics and Psychology from Columbia University. It will now be our pleasure to hear from Annie Ma Weaver.
Welcome to our session on Google Cloud's best practices for deploying and managing HPC workloads. My name is Annie Ma Weaver, and I'm the Partner Manager for High Performance Computing at Google. During this talk, I will describe HPC best practices by introducing our scalable HPC platform and infrastructure available on Google Cloud. I will also spotlight solutions available from Google and partners like Rescale to simplify running your preferred HPC applications, job schedulers, storage systems, and more. Let me start by introducing Google Cloud Platform and our vision and strategy for high-performance computing. We have 4 key pillars when thinking about how to make Google Cloud a great place to run HPC workloads. First, we make Google Cloud fast and affordable, bringing the latest and greatest HPC technologies like CPUs and GPUs, and building technology for HPC-specific workloads like MPI scalability. Easy and Compatible focuses on making our platform easy for HPC workloads for newcomers and HPC gurus alike. And compatible means integrating with partner applications, schedulers, and more, which leads me to Partner Preferred, which emphasizes our broad network of software partners and system integrators. Last but not least, we bring our customers the best of Google by engaging industry and ML AI experts and allowing you to take advantage of our Google differentiated technology and capabilities. Our HPC platform consists of 3 layers in yellow with our cloud infrastructure at the base, including compute, networking, and storage. Above infrastructure, we have development and deployment layers, which include partner integrations for essential elements like job scheduler, storage, or a complete HPC platform like what Rescale offers. You'll also find some of our core solution components like the HPC Toolkit, HPC VM images, and Batch that allow users to deploy and manage HPC workloads easily. Okay, zooming in on infrastructure building blocks, compute, networking, and storage. I'll focus on each building block separately and give you a better sense of how Google Cloud offers come together for your HPC workloads. Before I dive in further, I wanted to highlight how, over the last decade, Google has built the cleanest cloud in the industry. We have been carbon neutral since 2007 rather, including offsetting all our emissions since we were founded in 1998. However, carbon neutral is really only the starting point. It's about offsetting emissions. Your emissions can actually still be growing, so we need to move beyond that and start to think about reducing emissions. 2 ways to do that are, 1, to reduce the energy you use, and 2, make sure that more of that energy is produced from renewable sources. To reduce energy, we instrumented our data centers and used machine learning models to optimize cooling, with the result that a Google data center uses half the energy of a typical data center. For renewables, we work closely with power companies to understand the renewables mix in the energy grids where our data centers reside. And we work with those same providers, renewables providers, to make bulk purchases of renewable energy. We are the largest annual corporate purchaser of renewable energy. Because of these initiatives, since 2017, Google has matched 100% of its energy usage with renewables, which means that compute, data, and machine learning workloads in GCP have 0 net emissions. In accounting terms, that means our Scope 3 emissions are 0. Back to compute. Google offers a wide variety of VM families, and choosing the right VM for your workload is a best practice. We have our general purpose VMs, including some of our lower performing, cost-effective, efficient options like E2. And these particular processors work well for scale-out workloads like web hosting. Our workload-optimized VM families complement those, like our compute-optimized VMs, the C2 and C2Ds, as well as our accelerator-optimized VMs. What makes an HPC VM different from other VMs? Well, the HPC VM has several differences that make them a better fit for HPC workloads. First is the choice of hardware and the features that go into the VM. We choose high clock speed and well-balanced CPU types, high bandwidth memory, and high-performance GPUs to support compute-intensive and I/O-intensive workloads. These VMs also support disabling of SMT, also known as Intel hyperthreading, for optimal performance where SMT is not preferred. Virtual NUMA produces a direct mapping of host CPU to guest CPU, giving your guest operating system a view of the way it's truly laid out on the physical host machine, allowing for improved memory management and CPU pinning. It also ensures socket isolation and other optimized CPU scheduling. Third is our support for placement policies, which improves network latency. I'll go further into placement policies later in the session. Finally, there are a number of network optimizations, which include 100 gigabit per second VM throughput, 9K MTUs, an improved virtual NIC driver, and tunings which optimize HPC performance. And what do these performances make in terms of HPC performance in the real world? Well, if you take our latest C2D VM family as an example, we've seen a 66% performance improvement when comparing it against the N2D VM, which is our general purpose VM type and the previous generation of AMD EPYC CPU, and does not have the same kinds of HPC optimization. One Google Cloud customer with CFD workloads shared that running these simulations on C2Ds led to their reducing costs by 50% and simulation times by 30% compared to previous generation high-performance computing instances. When compared to on-prem instances, the customer reported that they were able to reduce simulation times by more than a factor of 3. In addition to CPU VM types like the C2D VM family, we also have multiple GPU types supported through our GPU VM families like our A2s. A2 VMs support up to 16 NVIDIA A100 GPUs per VM, and they're backed by Intel Cascade Lake CPUs, similar to the high-performance C2 VM family. Last but not least, I wanted to share a new VM type under the tau brand. Tau is a Greek letter that denotes the golden ratio. It is also the symbol for torque. Here it denotes performance. In our case, tau is the balance of performance and price with the right feature set for target workloads. And we thank Rescale for being one of our launch partners. Bulk API is an important best practice for everyone running HPC workloads at large scale. It combines two important capabilities to improve time to deploy large-scale HPC clusters. First is the ability to deploy up to 1,000 identical instances with a single API call. That dramatically decreases the time spent sending individual API calls for each VM creation. Second is regional deployment, rather than zonal deployment, which searches for capacity for you and adds flexibility to your HPC deployments to avoid stockouts, enabling your HPC VMs to be deployed faster. With these features, Bulk API can speed up large-scale instance deployments by up to 500% in our testing. Next, let's talk about storage. Choosing the right storage for your workload is an important best practice. Google has a variety of HPC storage options to fit your needs. Google offers managed services for object, block, and file storage, and has partnered with leading storage providers to support their file storage solutions. These storage providers include parallel file system offerings like Lustre, Spectrum Scale, GPFS, and most recently Intel Deos to support your most demanding scratch storage requirements. And we know that storage is not one size fits all, and HPC clusters achieve the best performance, reliability, and cost effectiveness by combining storage systems in a hierarchy of storage. That's why we built the storage transfer service to support customers that need to move data from on-prem into the cloud and between their multiple distributed storage systems. With the storage transfer service, you can use a Google service to manage a high-performance data movement for you. And when combined with the burst buffer capabilities in our partner scheduler offerings, it becomes a powerful tool to manage pre- and post-stage data as part of your overall HPC workflow. Google's networking is the third infrastructure building block. There are many best practices to achieve the best networking performance for your HPC workloads. Google's HPC VMs can be configured with our Tier 1 bandwidth, which enables up to 100 gigabit per second to and between VMs. Combine that with our predictable low latency, and you already have a very capable HPC system. But when you add on the types of tunings and optimizations that are available on Google Cloud through our HPC VM image, and things like our new Google Virtual NIC and 9K MTUs, as well as our placement policies, well, you can achieve extraordinary performance. Placement policies are a new feature of Google Cloud, and using them is an important HPC best practice. Placement policies allow users to manage their HPC VMs according to network topology, and there are two types, compact and spread. Spread is used for high availability purposes and isn't really interesting for most HPC use cases. Compact is specifically built for and supported on HPC VM families. It's designed to minimize network hops and therefore latency between VMs, which can dramatically improve performance for tightly coupled workloads. Placement policies can help reduce the total runtime of a workload, which is an important input for the overall cost for that workload. What are other ways to minimize cost? Well, we recommend the following best practices. First, use custom machine types, which allow you to define your own instance profile outside the bounds of the standard instance profiles. Using a custom machine type can reduce the cost of running a workload by up to 19%. Next, committed use discounts and other discounting programs are available, and you should talk to your Google account manager about what kinds of discounts and credit programs are available for you. Last but not least, spot VMs are a replacement for preemptible VMs and can be up to 91% cheaper than a standard VM with no set time limit like preemptible VMs had, which makes them even better for HPC workloads. When using spot VMs, we recommend focusing on loosely coupled workloads, checkpointed jobs, and MPI jobs with around 8 nodes on a job or less to minimize disruption and potential for impact from node preemption. Now let's turn to HPC solutions and partners for running HPC workloads in the cloud. We've covered the building blocks, but what methods are available for you to put together an HPC environment in the cloud? Broadly speaking, there are 3 approaches based on an analogy of making banana bread, which I know many of us did during the pandemic. 1, you can bake the banana bread from raw ingredients, assembling things like bananas, flour, and eggs that you procure and mix yourself. You're responsible for putting together the individual pieces and partner solutions to bake your own HPC cluster banana bread. This is how historically we recommended people build their HPC environments, with the support of partners and our professional services organization. Next, you can go and buy a banana bread mix, which is an easier option because most of the ingredients are already obtained for you. You can then follow the directions and add some customization, like a dash of cinnamon. And faster than the first method, you can have a loaf ready. That's the Cloud HPC Toolkit, a flexible toolkit designed to take all the individual ingredients, individual solutions from Google and its partners, and assemble them together in a way that's easy for you to configure and customize without having to go and find and measure each ingredient separately. And it has our HPC best practices built in for you, stemming from our own HPC experiences, so you don't have to make a lot of effort to ensure good performance. The last option is to go buy banana bread from a bakery. That's the batch path, where you can use our cloud-native managed batch service to deploy your workloads directly onto Google Cloud. It's supported by the Cloud HPC Toolkit, and although not having as many features as our partner scheduler offerings, it's a quick and easy way to get started running HPC workloads on Google Cloud. Regardless of which option you choose, you'll want to build your HPC workload on top of our HPC VM image. This is a turnkey CentOS 7-based image that launches with all the HPC best practices for MPI performance, including OS tunings, optimizations, and recommendations. It's easy to deploy and is already built into your partner offerings and HPC toolkit. We've seen an almost 25% reduction in runtime of the LS Dyna 3-car crash model across 8 VMs compared to a vanilla CentOS image. Deploying your HPC environment with the HPC VM image is a simple best practice that everyone should take advantage of. We've got a broad ecosystem of HPC partners across software applications, workload managers, storage systems, and systems integrators. We are thankful for our partners, including Rescale, who enable end-to-end HPC solutions for our joint customers. The Cloud HPC Toolkit is a modular toolkit written in Terraform and is designed to make it easy to deploy repeatable turnkey HPC environments with Google Cloud's HPC best practices built in. The toolkit consists of 3 key components. First, a blueprint of which is a YAML-based architecture of what your specifications for your HPC environment should be built to. Blueprints can be specific to a workload, general purpose, or focused on a partner's solution. The toolkit comes with several example blueprints, and also you can go to the community and find blueprints too, and customize them to your needs. Blueprints then refer to modules that the toolkit supports, and these modules break down into several types, like schedulers and storage. The modules are then deployed onto our HPC infrastructure. Let's see how these pieces come together and how the toolkit works to deploy your environment. When a user builds a blueprint, they reference modules. Modules are scripts that can be imported from public sources like GitHub, or can be built by a user for private or public use. The modules are configured in the blueprint through a set of variables in each module, and the modules come together to define all the components of an HPC environment, including the networking, storage, scheduler, compute resources, and more. The blueprint is then fed into the GHPC engine, which will import the HPC module code as needed and build a deployment folder with the scripts needed to deploy the complete HPC environment specified in the blueprint. The impact of using the toolkit versus doing it yourself is clear. A user need only write 59 lines of blueprint, which translates to 13,000 plus lines of total deployed code, thus dramatically reducing the amount of time needed to configure and deploy a complete HPC environment. Our customers have shared the benefits of HPC Toolkit for their production workloads. One organization can now create an HPC cluster in Google Cloud in a matter of minutes, while another has seen a significant reduction in the complexity of deploying HPC workloads in the cloud and improvements in automation and error mitigation. Simplifying our users' experiences of moving HPC to the cloud will improve everyone's ability to do more science, which is a collective goal of our HPC community. Finally, the batch service is an awesome new managed service for natively scheduling and executing batch jobs at scale on Google Cloud resources. It's a cloud-native job scheduler built from the ground up for Google Cloud, and it's a powerful tool for anyone from people looking to just get started running their workloads on Google Cloud to large customers building out their own custom HPC platforms. While it doesn't support all of the features in our established job scheduler partnerships, it does support scheduling features like job priorities, task retries, task timeouts, and both loosely and tightly coupled workloads, including MPI workloads. Batch runs on Google Cloud, Google Compute Engine, and supports features like spot VMs and custom machine types. Throughout this session, I've outlined several best practices for you to keep in mind as you start out or continue your journey to the cloud. First is choosing the right VM type. And make sure you choose an HPC VM type that matches your HPC workload. Be sure to use Bulk API to speed up your VM deployments. Choose the right storage, and don't be afraid to mix storage types. Data movement is simple with the Cloud Storage Transfer Service. Use the HPC VM network features like 9K MTUs, 100 gigabit per second networking, and best practices to optimize your networking performance. Again, especially for MPI workloads. Compact placement policies are a key networking feature that can mean a big difference in VM to VM performance. You should reduce your cost using custom machine types and spot VMs. Always deploy those VMs using the HPC VM image, which comes with our HPC best practices built in. Use the Cloud HPC Toolkit to build bespoke HPC environments to implement all of our HPC best practices out of the box. Or if you're looking for an even simpler way to deploy your HPC workloads, consider the new batch service for a fully managed HPC scheduler. Thank you for your time. Please let me know if I can help you expand your HPC environment to include Google Cloud. I hope you enjoy the rest of Big Compute 22.